Hi, now that we've taken a look at how to set up trig ratios and putting those into equations so we can solve for missing side lengths and angle measures of a right triangle, we're going to see how we can find this in the real world by using it to solve for things like the distance away from a building that a person is standing or the height of a building. And so two phrases that we'll need to know that we're going to use a lot of is used to describe angles. And so one is dependent on the line of sight of a person that's flying an airplane. So picture that his line of sight is the dotted line that you see on top versus the other person's line of sight on the ground level is formed by the horizontal line, dotted line that you see down below there. And I've gone ahead and traced it in that turquoise color. And then you'll see that when they're looking at each other, this is their pathway of their vision, is this transversal that cuts across. Now we see two lines that are parallel formed by their line of sight. And so things should come to mind for you guys in terms of angle measures. And so you'll see that there's an angle formed up on top here and an angle formed down below here, which you might recall as alternate interior angles. There is a letter Z formed with parallel lines. This is the transversal, these lines are parallel. So I always think of it as if the person is on the top looking down, either on a plane or on a building, and the angle that is formed by his line of vision is one in which he's looking down. Think of like if you're depressed, you're looking down. So this angle measure right here is called the angle of depression. Whereas if you're feeling elevated or your line of sight is elevated, then the line that is the transversal, his line of sight, with that of the horizontal, forms an angle that we refer to as the angle of elevation. Well, something you guys should notice right away is that this angle of depression and this angle of elevation should be what? Good if you guys are thinking it should be equal, right? Because they are alternate interior angles. So that's going to be something that might be useful for us as we set up the problems. And then another observation I'd like you guys to make that will help us out here is the fact that the vertical line or the altitude of the plane forms a 90-degree angle with your with the ground level so that we have a right triangle there. And so here, instead of using Pythagorean theorem, we're going to start to apply trig to help us solve for the missing piece of information. So I am going to ask that you guys all draw pictures for your examples for your homework assignment. So here, from a point 80 meters from the base of a tower, the angle of elevation, so let's go ahead and draw our tower and do my best here to draw a tower. It kind of looks like those towers in Mario Brothers here. Okay, so from a point 80 meters from the base of the tower, so here's the base of the tower, point 80 meters. So when they're describing a distance, that's going to be a horizontal distance. This is 80 meters. The angle of elevation is 28 degrees. So elevation means that the person is looking up. So we're going to picture the person here looking up to the top of the tower. And the angle of elevation is 28 degrees. How tall is the tower? So we'll go ahead and define the height of the tower as x. And using the information that we have, it looks like we have the opposite side from 28 degrees. And we also happen to have the adjacent side. So we want to think of, well, what has O and A in it? Well, TOA has O and A in it. T stands for tangent. So we're going to set up our trig equation as tangent of 28 degrees is equal to x opposite, and our opposite leg is x, and our adjacent leg is 80. So now we should have had plenty of time to practice punching this into the calculator. So I'm going to have you guys take a moment, solve this, multiply both sides by 80. So on your calculator, either through Desmos or your scientific calculator, you guys can enter in 80 tangent of 28 degrees and see what you guys get. Okay, so we should, if we are approximating this out to, and your homework will describe how they want you to round, but if they wanted you guys to round out to the 10th place, my answer is 42.5. Since, whoops, not degrees, but the fact that we're measuring the height of a tower, we're going to use the same measurements that were provided in the problem itself, being consistent with the fact that it was meters to measure the distance away the person is standing from the tower. We're going to say that this is also meters, 42.5 meters. On example 2, we're going to see ladder problems from geometry all the way on to AP Calc, but a ladder is 20 feet is leaning against the side of a building. So let's picture the ladder leaning against the side of a building. Make that ladder actually look like a ladder here. Okay, so here's our right triangle. And let's label certain things, that information that's given. The ladder is 20 feet, so the measure of the hypotenuse of the rectangle is 20. If the angle formed between the ladder and the ground, so when we're trying to find that, we're going to trace out what we have. The ladder formed by the ladder and the ground, so that's going to be our angle of elevation. That is 75 degrees. How far is the bottom of the ladder? How far is the bottom of the ladder from the base of the building? So they want this length right here. And that we're going to call x. Okay, so as we start to piece together what function to use, what trig function to use, we're going to figure out what we have here. What we have is we're standing at 75 degrees. We have the adjacent leg and we have the hypotenuse. So write that out, adjacent hypotenuse. Which trig function should we use? Good, cosine, right? So the cosine function is cosine of the angle at which we're standing is equal to the adjacent x over 20. And so to solve that, again, we multiply both sides by 20. So x should be equal to 20 cosine of 75. By the way, something to note, if you ever get directions that say present your answer in calculator ready form, this would be considered calculator ready form. It's the step right before you're going to enter into the calculator to come up with what the approximation is. However, in our case, most of the times we're going to present the decimal approximation. Again, assuming out to 10th place, go ahead and punch that into the calculator, see what you guys get. You should have gotten 5.2 feet. And remember, as you go through this video, if you need to stop, pause, please do so as we're doing the problems. And, you know, if I'm writing too fast, go ahead and do that if it helps. Okay, we're going to move on to the next page. On the next page, you have example 3. When the sun is 62 degrees above the horizon, a building casts a shadow that is 18 meters long. How tall is the building? So we have here a building. We have the sun, let's say, behind the building, casting its rays and forming a shadow. And remember, this is the part that I have students kind of confused over what a few things are. One, when they're talking about above the horizon, they're talking about the horizon being the horizontal line of sight that is down below here. Okay, so 62 degrees is right here. And the building casts a shadow, and where is your shadow? Is your shadow the hypotenuse? Is it on the ground? So always remember that the shadow is referring to, if you look at a shadow, it's on the ground. So this is going to be your shadow, and the shadow is 18 meters long. How tall is the building? So we don't know what this is. So that is x. And let's go ahead and see which trig function we would use for this. So if I were labeling it, this would be my adjacent leg to my angle measures, and this would be my opposite. So what has O and A in it? That is tangent. Good. So tangent of the angle measure is equal to the opposite leg, x, over the adjacent, which is 18. So calculator ready form would say x is equal to, remember the squiggly one is approximately, but we know it's exactly equal to 18 times tangent of 62 degrees. Now, if we enter that into the calculator, we are going to come up with an approximation. And so that approximation for this one would be, go ahead and hit pause and then enter it in. I want to make sure you guys are following along with that and good with the values on the that I'm presenting here should match the values that you guys get on your calculator. Getting in that practice, because you will have that to do that independently on your own. Okay, so good. You should have gotten 33.9. And we want to be consistent since this is measuring the length of the building, and the shadow is 18 meters. We're going to say it's 33.9 meters. Okay, on example 4, you have a kite, and the kite is flying at an angle of elevation of about 55 degrees. Okay, so let's go ahead and draw our kite. Okay, we'll draw some strings to here. Okay, so here's our kite, it's flying, and there's an angle of elevation to the kite, which means that we're on the ground and we're looking up at the kite. Let me fix this a little bit here. Okay, so angle of elevation is about 55 degrees. Ignoring the sag of the string, so they're saying, assuming that this string is taut, find the height of the kite if 85 meters of the string has been let out. So if we're measuring the string, it should be 85 meters. So that means the hypotenuse is 85 meters. And the height is always the altitude. So imagine dropping a perpendicular line down to the ground level. They want us to figure out what that is. Okay, so if I had to label what we had to then determine the trig function, I have the opposite and I have the hypotenuse. So which one has the O and the H in it? That should be the sine function. So sine of the angle at which we're standing is equal to x over, so sine opposite over hypotenuse is x over 85. Okay, so when we calculate this, and for this one I'm going to go ahead and do this with you guys on Desmos. We're going to enter in x is equal to 85 times sine of 55. Okay, so let me pull up Desmos calculator, 85 and sine of 55. So 85 sine of 55 should get me 69.6. So 69.6. So x is approximately 69.6, in this case, meters long. All right, so example 5. So this one's a little bit more in depth here. From the top of a vertical cliff. And let's draw our vertical cliff. 40 meters high, so we know that the cliff is 40 meters high. A fisherman spots a sailboat. So fisherman's up here. He spots a sailboat. With an angle of depression of 34. So they're talking about this guy's line of vision, and assuming he's looking down at the boat here, the angle of depression is up on top here as 34 degrees. And they want to know how far is the sailboat from the base of the cliff. So they want us to calculate the distance between the cliff and the sailboat. So that's this ground level horizontal line. And so if I look at the angle of depression and thinking back to what we discussed at the very start of the lesson, these two lines are parallel, so that this angle of depression must be equal to this angle of elevation. So I can assume that this angle measure is also 34 degrees. And so if I wanted to find out what the distance is away from the base of the cliff that the sailboat is, then this is my x. And so to see what we have the opposite, we have the adjacent. So this is going to be a tangent one, tangent of the angle measure, 34 degrees. And the reason, by the way, that I brought the angle measure inside here as the angle of elevation, as opposed to just treating it as the depression, is that then it forces me to use this right triangle that I have. This angle of depression is outside of the triangle and I wanted to bring it inside. So tangent of 34 degrees is opposite, which is 40, over adjacent, which is x. Now remember, to solve this, we interchange the x and tangent of 34. So x is equal to, calculator ready form would be 40 over tangent of 34. And so I would get x is approximately 59.3 meters. So very nice on this. Let me know if you guys have questions at tutorial or in class.